Welcome to Study Loop.
The rate of heat loss from a pipe of inner radius, this is R1, outer radius, sorry, I just wrote the diameter for this. So this is R1, and whereas the outer radius of a pipe is R2. So R2. So then we can write a heat loss, rate of heat loss. We can write, this is for part A, rate of heat loss, delta Q over dt. dq over dt is given by the definition of heat loss, that is a K times a constant surface area times the change in temperature through a radial distance dr. Then we can replace area by 2 pi RL. Then this expression becomes a minus 2 pi R L dt over dr. Then we can extract the dr and separate it out, which is dr over r, and write a new expression which is a minus 2 pi k times L divided by dq. We bring out dq downstairs, and this becomes dq over dt times delta t. Then we will integrate on both sides. From here we will integrate from t1 to t2, where on left hand side we will integrate from radius 1 to radius 2. Then we can find the rate of evaluating these integrals. Then we get dt over dq over dt will be equal to 2 pi times k times the temperature difference between in and out, which is T1 minus T2, times the L, length of the pipe, divided by ln of the two radii, which are R2, divided by R1. So this is our expression needed for part A. Part B, we are asked to find the rate of change of temperature delta T over small delta t. Capital T is for temperature and small t for a time. We can find this by writing an expression for dq over dt in terms of mass and specific heat. This becomes delta t over t. Then we will solve for delta capital T over delta small t from the above, from the expression we just derived in part 1, and then write an expression which is 2 pi times k times L times the change in temperature difference between in and out, which is T1 over T2, T1 minus T2, sorry, divided by mass times C, specific heat, times ln of R2 divided by R1. And substituting the value, this gives us a rate of change of temperature, which is 4.8 Celsius per second. In part C, we are asked to find the temperature drop for 8 centimeter for the length of pipe, which we can find it by dividing 4.8 divided by 8 centimeter, and this gives us 0.60 degrees per centimeter drop. End of the problem. Thank you for watching.